Good morning, Year 4, and welcome to our final maths lesson of the week. Well done for all your hard work so far. Today we're going to be looking at adding and subtracting fractions within 1. So I'm just going to share my screen with you to get started. Okay, so your do now for today is recapping changing mixed numbers into improper fractions like we practiced yesterday. Now, there are some pictures to help you with the first 3 questions, and the steps are also on the side, but do have a go at the second lot of questions with the steps if you can. You can draw your own representations if you still need those to support you, but try and use the steps to follow as well. So we're just going to quickly do the first one together just to check that we've remembered from yesterday. So the first one is 1 and 2 quarters. So you can see I've got 1 whole and 2 quarters here, okay? So the first thing I need to do is write the denominator the same. My denominator is 4 because there are 4 parts in 1 whole. So to change my mixed number, I now need to multiply the whole number by the denominator. So I need to multiply 1 times 4. Okay, so I'm going to keep that in my head. I know 1 times 4 is 4, and then I need to add the numerator. 4 add 2. 4 add 2 is 6, so that becomes my new numerator for step 4 to make that an improper fraction. So let's just check that I've done that correctly. Let's count the parts in the picture. So I have 1, 2, 3, 4, 5, 6. Fantastic. So 1 and 2 quarters is the same as 6 quarters. So I'd like you to follow the steps for the next questions and then come back when you're ready. Off you go. Fantastic. Hopefully you've managed to have a go at all of those. I'm just going to pop the answers up on the screen now for you to mark your work. So we did the first one together. We should have 7/5 for number 2, 17/6 for number 3, and then on this side we had 7 quarters, 13/5, and 22/6. Well done if you managed to get all of those correct. Do check your answers and have a think about where you went wrong if you've got any of them wrong there. Okay, so as said, today we're going to be adding and subtracting fractions within 1. So that is fractions that are less than 1, our unit and non-unit fractions. So our keywords: numerator, denominator, whole, bar model, part, and add and subtract. So we should be really familiar with all of these words now because we've been using them in all of our lessons. So let's get started. Okay, so we've got our steps to success at the side, and we're also going to be using our bar models to help us check our answers today as well. So my first question is 2/5 plus 2/5. Now I've color coded that so you can see on our bar model how I've represented it. So I have 1, 2, 3, 4, 5 parts in total on my bar model because 5 is the denominator, telling me how many parts there are. So I'm adding 2/5 and another 2/5. So I've labelled 1, 2 parts red and 2 parts blue. So now I can add together that I have 1, 2, 3, 4 parts in total. So altogether, I have 4 out of 5 parts are shaded, okay? So I know my answer is going to be 4/5, but we're just going to check with our steps to success that we can do that as well. So the first thing I need to do is add or subtract the numerator, which is the top number of my fraction. So I have 2, add 2. I know it's add because I've got my add symbol, okay? We're going to be looking at subtraction as well today. So 2 add 2 equals 4. So that stays as my numerator. And then the denominator stays the same, which is the bottom number. So I don't add 5, it just stays as 5. Now the reason that it doesn't get added is because the parts have not changed. If I added them, then I would have 4/10. And that is a completely different fraction. That is not equivalent. So 4/10 would look like this bar model here. And as you can see, the parts are a lot smaller, so it is not equal. So I'm not adding the denominator, I just add the numerator because that is how many parts that I have. Okay, let's keep going, have a look at some more examples. So this time I have 3/6 plus 1/6. So again, I've color coded it for you, but let's just check on our bar model. So I have 6 parts in total. 1, 2, 3, 4, 5, 6. There are 6 squares, 6 parts in my bar model. So I've shaded in 3 red to represent 3 6. And I've shaded in 1 blue part to represent 1 6. So now I can add the parts together. So I have 1, 2, 3, 4 out of 6 are shaded. Okay, let's just check with our steps to success. So add or subtract the numerator. I'm adding this time, so I need to do 3 add 1. 3 add 1 equals 4. And remember, my denominator is staying the same because I still have the same amount of parts. So 4 out of 6 are shaded. 3 6 plus 1 6 is equal to 4 6. Okay, let's have a look now what happens when we add in another fraction. I'm still following the same steps, but I just have an extra fraction to add. So this time I've got tenths. My bar's cut into 10. Let's just check the parts. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 parts in total. So I have 3 red parts, 3 are shaded, 3 tenths. 4 blue parts are shaded, which represents 4 tenths, and 2 green, representing 2 tenths. So now I can count how many are shaded in total because I'm adding them together. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9 parts in total. This one is not shaded. So 3 add 4 add 2 should be equal to 9. So I can pop 9 on my numerator because I know if I add my numerators together, 3 add 4 is 7, 7 add 2 is 9. So I have 9 parts in total as we've just shown on the bar model. Then my denominator, what happens to my denominator? What is my denominator going to be in this fraction? So I'm saying it should be 30. Is that correct? Hopefully you're saying absolutely not, Miss Jones, that is not correct because the denominator needs to stay the same. There are not 30 parts, I'm adding tenths, there are 10 parts, so there are 9 tenths in total. It needs to stay the same. Okay, so let's have a look at some examples with subtraction now. So I have 7 eighths minus 4 eighths. So again, I'm going to use my bar model to help me, but we can still follow our steps as well. So I've shaded in 7 parts, 1, 2, 3, 4, 5, 6, 7 out of 8 parts in total, representing 7 eighths. So this time I'm taking away 4 eighths. So I'm going to cross them out and count 4 so I can see how many parts that I have left. So I have 7 eighths, I'm going to take away 1, 2, 3, 4. So I've taken away those 4 eighths that this part is representing here. So how many do I have left? Well, now I have 1, 2, 3 parts left. So 7 eighths minus 4 eighths, I have 3 eighths remaining. 3 out of 8 are left. So let's just again check with our steps of success. Add or subtract the numerator. So I did 7 minus 4. 7 take away 4 is 3. And then again, my denominator needs to stay the same. So my denominator should be 8 because there are 8 parts. Remember, I don't add them together. Let's have a look at one more, and then we'll have a look at 3 fractions. So this time I have 7 ninths take away 2 ninths. Sorry, I was just checking I had the right question now because it's very similar. So 7 ninths take away 2 ninths. So again, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so 9 parts in total. Again, I've got 7 shaded in this time, representing my 7 ninths. And this time I need to take away 2 ninths. So I need to cross off how many parts? I'm going to be crossing off 2 parts in my bar model to represent 2 ninths. Good, so 2 parts I'm going to cross off. So now I can see how many I've got left to find out 7 take away 2. 1, 2, 3, 4, 5. 7 take away 2. My number bonds, I know that is 5. So 5 needs to go on my numerator. And my denominator, remember, is staying the same. So I have 9 on the bottom. So 7 ninths take away 2 ninths is equal to 5 ninths. Okay, let's look at one more example with 3 fractions this time. So I have 11 twelfths and I want to take away 5 twelfths and 3 twelfths. So I've shaded in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 out of 12. Okay, so that is representing this fraction here. So the first thing I'm going to do is just focus on taking away 5 twelfths. So I'm going to cross off 1, 2, 3, 4, 5. So I've done the first one there, and then taking away 3 twelfths. So I need to cross off another 3 parts. 1, 2, 3. So how many are left out of the 11? I now have 1, 2, 3 remaining. 11 take away 5 is 6, and 6 take away 3 is 3. So I can follow my steps and I will still get the same answer for my numerator. So I have 3 remaining. And again, my denominator needs to stay the same. So I have 3 twelfths left. Okay, let's look at a slightly different now. I'm working with some missing fractions. So 3 twelfths plus something is equal to 11 twelfths. So I need to find out the missing fraction. So I need to look first, I'm adding. So 3 add something equals 11. 3 add something equals 11. So I know it's add, and I'm trying to find the missing one. So I need to do the opposite, the inverse. I need to do 11 take away 3 to help me find my answer here. So I'm going to do that in my head. 11 take away 3. Hopefully you've got the same answer as me. I should have 8. So I'm just going to check that to make sure it works the other way, to make sure it's correct. 3 add 8, so 8, 9, 10, 11, fantastic. So that works on the top there. So I've done the first part, I found my numerator. Now I need to think about the denominator. So the denominator I know stays the same. So this one must also have been 12 because I've got 12 on both of these ones here. Okay, so let's have a think about this one. So this time it's subtraction. So 7 minus something equals 3. 7 minus something equals 3. So I know that 7 is there. I need to think about what have I taken away to get to 3. So if I have 7, I'm going to put it on my fingers to help me. I need to take away 1, 2, 3, 4 to get to 3. Okay, so I know my numerator is 4. And you can also draw your bar model to help you if you need to check. Then my denominator would also be 9. Okay, so that's what you're going to be doing on some of your apply questions and use today. So I just wanted to go through that just to make sure you know what you're doing. So let's just have a look now at a couple of word problems to help you as well. So Lily eats 3/8 of cake and Mo eats 2/8 of cake. What fraction of the cake have they eaten all together? So first of all, I need to find my correct calculation when I'm doing a word problem. So a key word in there that's going to help me is what fraction have they eaten all together? So I know that I'm going to need to add them together to find the total. So I've got 3/8 and 2/8. So that is going to be my calculation. So 3/8 plus 2/8. So I've drawn my bar model out to help me. If you're confident, you don't need to draw the bar model to help you. You can follow the steps to success, but I'm just going to use the bar model as well just to show you if you want to do that later on your independent work. So I know I need 8 parts, so I've drawn 1, 2, 3, 4, 5, 6, 7, 8. So I've got 3, 1, 2, 3, and then I need to add 2 8s. 1, 2. Okay, so I've done 3 8s and 2 8s. Now I can add them together. So I have 1, 2, 3, 4, 5 parts are shaded in. So I can do my numerator as 5 and my denominator stays the same. So what fraction of the cake have they eaten altogether? They have eaten 5/8 of cake altogether. Let's look at another example, which is subtraction. So Arlo walks 6/7 of a mile to school. Oliver cycles 2/7 less than Arlo. What fraction does Oliver travel? So this time I need to think about what calculation I'm going to be doing because it might be different. So I'm going to look for some keywords. And now I'm looking for what Oliver travels. And there's a key word in there that's going to help me, less. So I know Arlo goes 6/7 of a mile and Oliver's is 2/7 less than Arlo. So I know my calculation this time is going to be 6/7 minus 2/7 to try and find out what Oliver travels. So again, I'm going to use my bar model to help me represent this. So I have 1, 2, 3, 4, 5, 6, 7 parts because that is my denominator. But I know I'm starting with 6 this time because it's a subtraction. So I'm going to do 1, 2, 3, 4, 5, 6. Okay, so I've got 6/7. So 6/7 subtract 2/7. So I'm going to cross them off like we practiced before. 1, 2. So I started with 6/7. I've crossed off 2, and now I have 1, 2, 3, 4 remaining. So 6 take away 2 equals 4. Remember, I need to make sure my denominator is the same. 4/7. So what fraction does Oliver travel? He travels 4/7 of a mile. Okay. Okay, we're going to move on to our independent tasks now. If you feel you need to go back and watch some of those and have your steps to success up while you're doing your independent work, you can feel free to go back through the video and have a look at those. For the first part, you're starting off with adding and subtracting fractions. If you're doing band 1, you've got the representations there to help you. So do use the bar models, or you can draw your own at home if you need to. For band 2, you've got some addition and subtraction at the beginning, and then you've got some missing number problems as well. So again, go back to that if you need to have a look at that on the video. And similarly for band 3, you have some more missing number problems there as well. And then you can move on to your reply questions with some word problems and again some missing number problems and your reasoning at the end. Okay, because we're doing addition and subtraction today, make sure you check which calculation you should be doing. Check for that symbol and make sure you're really clear on that first. When you've finished, make sure you check your answers on the answer sheet as well. There's also a little challenge there today as well, so it'd be great for you to see some of you doing that on Seesaw. Okay, I'm just going to stop sharing my screen. Okay, well done for a fantastic week, everyone. I've been so impressed with all of your effort on Seesaw. People doing lots more work than they would usually do in school. You're doing lots of bands at home. Remember, you just need to focus on one of the bands, but if you do want to move on to the next ones and challenge yourself, then that is great work. So fantastic, and keep it up. We're going to be continuing with fractions a little bit more next week, so do keep practicing, and we'll be spending another week looking at some more adding and subtracting and some more word problems. So lots coming up. So have a lovely weekend, and I will see you on Monday. Bye.